Good day everyone, welcome back to my channel Spark Scholar. So in today's video we'll be running an IQ test on applied electricity course. And don't forget, this course, applied electricity, mainly covers DC machines. DC machine where we'll be having motors, generators and transformers. Right, this is the first aspect of the course. Then we have the second aspect, which deals with equivalent system, the one that talk about three-phase balance system. Then we have diodes, PN junction and others. But however, this first IQ test covered only machines, right? Only machines, which is generator, motor and transformer. So we have already uploaded like 3 videos on this topic. So those videos that we have uploaded, which are the first one on DC machine, then the second one on AC machine, and the third one on transformer, these are the 3 videos that this IQ test is mainly on. So if you really want to know the exact answer or how the answers of this IQ test were derived, then try to go through the videos, and also you can relate to other textbooks for more understanding. So actually this IQ test consists of around 30 multiple answers test. So you have options from A to D to select from. So in this video I'll be giving you the question and selecting the correct answer, and also giving you the main reasons why the answers are correct. So after watching through the video, if you have any question, then you can post on the comment link. And also, if you think our answer is not correct based on a certain reason, then you can also post it on the comment section. So stay tuned as I take you through the IQ test on applied electricity. So in 222 IQ test, so choose the correct answers. So let's go to the first question. Question number 1. An electrical machine is a device that converts dash A. Heat energy to light energy, B. Electrical energy to mechanical energy, or mechanical energy to electrical energy, C. Chemical energy to sound energy, and D. Solar energy to wind energy. So the correct answer is B, right? B, because we said an electrical machine is it converts electrical energy to mechanical energy. So if it's converting electrical energy to mechanical energy, you call it what? Motor. Or mechanical energy to electrical energy, and this is what? Generator. So the correct answer is B. Question number 2. A DC machines are mainly classified into dash A. Alternators, B. Transformers. A DC machine are mainly classified into dash A. Alternators and transformers, B. Motors and generators, C. Induction and synchronous machines, D. Primary and secondary machines. The correct answer is B. DC machines are mainly classified into motors and generators. And don't forget, there are some other textbooks that will tell you motors, generators and transformers. However, the options we have before us did not mention transformer alongside with motors and generators, right? That is why you see the correct answer to this option is just motors and generators. Question number 3. A DC motor converts A. Mechanical energy into DC electrical energy. B. AC electrical energy into mechanical energy. C. DC electrical energy into rotational mechanical energy. And D. Mechanical energy into chemical energy. The correct answer is C. A DC motor converts DC electrical energy into rotational mechanical energy. That is why it's called what? A motor, because it converts electrical energy into mechanical energy. And now, since it's converting DC electrical energy, then it means it's what? DC motor. So it's because of the DC electrical energy you will be able to differentiate it from what? AC motor. So the correct answer is C. DC electrical energy into rotational mechanical energy. Question number 4. In a DC series motor, the feed winding is connected A. in parallel with the armature, B. in series with the armature, C. separately from the armature, and D. across the supply only. The correct answer is B. Is connected in series with the armature, and that is why it's being called DC motor. Question number 5. In a DC series motor, the current relationship is A. The total current equals armature current plus feed current. B. Armature current equals feed current equals total current. C. Armature current equals feed current minus total current. And D. Current equals voltage all over resistance only. The correct answer is B. Since it's DC motor, since it's series motor, then all the currents are the same because they are connected in series. Subsequently, we'll be reading just the question and choosing the answer. Definitely, if you want to know the options before the answer, kindly pause the video so that you'll be able to read the options first before the correct answer. Question number 6. Which DC motor has very high starting torque? Which DC motor has very high starting torque? The correct answer is B. DC series motor. Yes, DC series motor have very high starting torque, unlike shunt motor. Question number 7. The speed regulation of a DC series motor is generally poor. Because the current are the same. Once the current are across the load is affected, then everything is what affected. Then number 8, in a DC shunt motor, the feed winding is connected. The answer is already showing. It means it's what? B. in parallel with the armature. Yes, the feed winding is connected in parallel with what? The armature winding. Question number 9. The current relationship in a DC shunt motor is dash. The current relationship in a DC shunt motor is dash. The correct answer is B. Don't forget, when we say shunt, it means we are talking about what? Parallel. It means the feed winding and the armature winding are parallel. And now, since they are parallel, then it means when the total current is coming into the circuit, it's going to split between the two feeds, which is the armature and the feed. So when you summation of what the armature current and the feed current, which is the shunt current, will give us what? Our total current. Question number 10. A DC compound motor has dash. A DC compound motor has both series and shunt feed windings. Yes, that is why it's called what? A compound motor. Now don't forget, for the compound motor, it's either is what? Long short or is short shunt. Question number 11. In a long shunt compound motor, as the shunt feed connected across in a long shunt compound motor, as the shunt feed connected across dash. Now we say we have long short and short short. So for a long short, it's already telling you that the short winding is far from the armature winding, right? Which means the feed winding, the series feed winding is connected directly to the armature winding, then the shunt winding is parallel to both the series winding and the armature feed winding. So the correct answer is C. Question number 12. A DC generator converts what? A DC generator converts what? And don't forget, we said a generator converts mechanical energy into what? Electrical energy. Then since it's DC, then it means a DC generator will definitely convert to the correct answer is what? A, because here they did not show any option for what? AC electrical energy or DC electrical energy. Yeah, it means the correct answer is is B, which convert mechanical energy into direct current electrical energy, right? It convert mechanical energy into DC electrical energy. So the correct answer is B. Question number 13. Question number 13. In a DC series generator, okay, now before we can even choose our answer, it's better we just read out the options so that at least we can get them. A. Armature, feed and load currents are the same. B. Feed current is 0. C. Load current is always less than the feed current. And D. Current flows only in the armature. And don't forget, this is what? DC series generator. The correct answer is A. In a DC series generator, armature, feed and load currents are the same because they are connected all in what? Series, so the same current flow through them. Question number 14. In a DC shunt generator, a DC shunt generator is commonly used where constant DC voltage is required. A DC shunt generator is commonly used where constant DC voltage is required, because we said in a DC shunt generator it has what? Voltage regulation, unlike series DC generator, right? A DC shunt generator has voltage regulation, so it's commonly used where constant DC voltage is required. Question number 15. An AC machine uses dash. B. Alternating current, and that's why it's called what? AC, because it uses what? AC. Question number 16. In most AC machines, the armature winding is located on dash. And don't forget, AC machine and DC machines are different in terms of what armature winding location. So in most AC machine, the armature winding is located on the stator. Yes, it's located on the stator, while the feed winding is located on the rotor. Question number 17. An induction motor is also called dash. An induction motor is also called dash. A, we have synchronous motor, we have asynchronous motor, we have DC motor, and we have transformer motor. So an induction motor is also called what? Asynchronous motor, which is B. The correct answer is B, asynchronous motor. The question number 18. The rotor of an induction motor runs dash. Exactly at synchronous speed, B is slightly below synchronous speed, and C above synchronous speed, D at zero speed always. So the rotor of an induction motor runs slightly below synchronous speed, which means the correct answer is B. The rotor of an induction motor runs slightly below synchronous speed because of slip. So the slip will tend to reduce the speed by a small amount. So question number 18. For question number 19, the difference between synchronous speed and rotor speed is called slip, which is option C. So the correct answer is C. The question number 20, a synchronous motor operates below synchronous speed, B at synchronous speed, C above synchronous speed, and D without magnetic field. So a synchronous motor operates at synchronous speed. The correct option is B, and that is why it's called what? A synchronous motor, because it operates at synchronous speed. Question number 21. A synchronous motor is called a doubling excited machine because it has dash A, two shafts, B, two loads, C, stator and rotor magnetic field, and D, bearing. The correct answer is C, because a synchronous motor has what? A stator and rotor magnetic fields, because you have to excite the stator field and also the rotor field. That is why it's called what? Doubling excited machine. So the correct answer is C, stator and rotor magnetic field. Question number 22. One important application of a synchronous motor is dash, power factor improvement, battery charging only, radio transmission, and DC welding. Oh, the correct answer is what? Power factor improvement. Power factor improvement, which is what? Option A. Question number 23. An AC generator is also called dash. An AC generator is also called dash. An AC generator is also called what? An alternator. So the correct answer is B. An AC generator is also called what? An alternator. Question 24. Question 24. A transformer operates on the principle of dash. The correct answer is B. Transformer operate on the principle of what? Electromagnetic induction. Right? And don't forget, and this electromagnetic induction, because we have self-induction and what? Mutual induction. So transformer precisely operate with the principle of what? Mutual induction, and it's called what? Electromagnetic what? Induction. So for a better response of a better understanding of this, go and watch our video on transformer. Question number 25. A transformer is a rotating electrical device. A transformer is dash, a rotating electrical device. B, a static electrical device. C, a mechanical pump. D, storage battery. The correct answer is B. A transformer is a static electrical device. Question 26. The winding connected to the input supply of a transformer is called dash. The winding that you are connected to your source, right, of a transformer is called dash. The correct answer is B. It's called what? The primary winding. Question number 20, what now? Should be 27, right? Question number 27. 27. The winding connected to the load of a transformer is called dash. Is B. Is called what? The secondary winding. So the secondary winding is where the load is connected to. Question 28. A step-up transformer has what? Now we are trying to compare the turns ratio and the voltage ratio, right? We want to compare them. Now, for a step-up transformer, looking at the step-up transformer, the secondary turns supposed to be higher than the primary turns, and secondary voltage should be higher than the primary voltage. So the correct answer is option A. The NS is greater than AP and the VS is greater than VP. Question number next, question 29. A step-down transformer has dash. Now we are still trying to answer this question based on the number of turns. So for a step-down transformer, the secondary winding is less than the primary winding. So the secondary winding is less than the primary winding, or the primary winding is greater than the secondary winding. So the best option, the correct answer to this question is B. Question 30. An isolation transformer has a turns ratio of 1. The correct answer is C. An isolation transformer has a turns ratio of 1. So attempt the following questions. So at the end, try to attempt the following questions. Just pause the video and read the question. Okay, question number 1. A DC motor takes a supply current of 25 amps. Determine the armature current and the field current. Don't forget, this is what a DC motor. Question number 2. A DC shunt motor draws a total current of 40 amps from the supply. If the field current is 3 amps, calculate the armature current. Question number 3. A DC shunt generator has an armature current of 35 amps and a field current of 2 amps. Calculate the load current. A transformer has 1,200 turns on the primary winding and 300 turns on the secondary winding. Determine the turns ratio and state whether it is a step-up or step-down transformer. A transformer has a turns ratio of 1:4. If the primary voltage is 240 volts, calculate the secondary voltage. Question number 6. A step-up transformer has 200 primary turns and 1,000 secondary turns. If 230 volts is applied to the primary winding, calculate the secondary voltage. Question number 7. An ID transformer has a primary voltage of 240 volts and a primary current of 5 amps. If the secondary voltage is 120 volts, calculate the secondary current. Question number 8. A transformer has 500 turns, frequency of 50 Hz and maximum flux of 0.01 Weber. Calculate the induced EMF using this formula. E equals 4.44 F N flux maximum. Question number 9. A transformer has a primary to secondary turns ratio of 3:1. If the secondary impedance is 8 ohms, calculate the impedance seen at the primary side. Question number 10. A transformer has a transformer ratio. Normally transformer ratio is what? NP all over what? NS equals to 0.5. State whether the transformer is step up or step down or isolation transformer. Thank you for watching. Thank you for staying up to this time. Please try to answer those questions and comment your answers on the comment section. So for now, I say bye and have a nice day. Spark Scholar, from idea to paper.